Hi, in this video I'm going to talk about implementing and optimizing models for promotion data. First, the data was selected, cleaned and strings converted to values. Great care and consideration went into replacing null values. For example, in education they were replaced with the word unclassified and later with 0 to indicate the person did not have an education. More on this in the report. I then visualized how many times promotions occurred. As you can see, promotions occurred only about 8% of the time. The data was checked for duplicates and we used the standard scaler to normalize the data. I went back and forth on dropping age and gender due to them being protected characteristics, so I developed models with and without them, but the results indicated that these features were not as important and the results actually improved a little. The data was split and SMOTE applied, which is the oversampling technique. I also implemented an undersampler and the other forms of oversampling, but this one worked best, and I also visualized the data after it just to make sure it worked. I also performed and visualized feature selection. I tried random forest, ANOVA, SelectKBest and even a decision tree, but I went with SelectKBest due to it being the most reasonable and best performing. This is also discussed in the report. I selected the top 7 features. Finally, we arrived at the algorithms used. So, as the report mentions, the reviewed papers established random forest is the best performing, so I had to implement it. Random forest builds on decision trees, which is why I decided to implement them. One report mentioned gradient boosting as the best algorithm, so I implemented it. And seeing that it was the best performing algorithm for me, I had to try extreme gradient boosting. I also implemented AdaBoost because I was curious of how it would perform. Finally, I implemented an ensemble technique where voting equaled hard, hoping I can get an even better prediction as it combined the decision tree, random forest and the best performing gradient boosting. Spoiler alert, it did not achieve a better prediction than gradient boosting. I printed a classification report and the algorithms performed pretty well. They sat around F1 0.9, but I was able to improve this with hyperparameter tuning, with which gradient boosting rose to F1 0.97. Then I wanted to engineer some features, as you can see up here, to see if I can get up to 99%, but this did not work in my favor, even though SelectKBest found the newly engineered interaction term to be important. I also implemented cross-validation with 5 folds to make sure the algorithms are performing well, and printed the results over and over again just to get the best hyperparameters. Finally, I visualized the findings and printed the classification report. The biggest obstacles I encountered was when I was first applying SMOTE and it did not actually work and my models were not able to learn, which was pretty traumatic, but tearing into the code helped me figure out that I in fact did not apply it. Once I fixed that, the models worked well. I encountered some limitations such as long learning rates where a model would learn for 3 hours and then my computer would die, and also the dataset, while it has 52,000 rows, it only has about 11 useful features, out of which one is region and another department. While they may play a role, it can't comprehensively capture a person's identity. So overall, I'm happy with the project because it achieved slightly better results than most of the reports except for one, which achieved 99%. I have reviewed their paper many times trying to understand why. So for the future, maybe experimenting with the decision tree, which they used for the feature selection, and other oversampling techniques could get this F1 to 99%. All right, thank you so much. Bye.